All right, good morning, everybody. Today we're going to talk about the last set of problems from the Chapter 7 review packet that have to do with the exponent rules, and that is numbers 34 through 42. So let's get started. Now, these last ones actually are, some of these are tricky. They're definitely the hardest ones in the packet because they're at the end of the section. So let's look at the first one now. If we're looking at this first one, it's a fraction. And as I said in the previous video, anytime you have fractions, you always want to look at the numerator first and the denominator second separately. Looking at those, there is nothing to simplify. Therefore, we can now look at the fraction as a whole. Now, the first thing that I notice as I'm kind of scanning through there, we have this -3 and this 18. Those are definitely going to simplify. So I'm going to write this as a fraction, although I'm not sure that we're going to need it in a fraction form. But -3 on the top and 18 on the bottom are are they have a common factor, and that common factor is -3. So we're going to divide both of those by -3. So -3 divided by -3 is 1. So we're actually not going to write anything on top. Now, 18 divided by -3 is -6. Okay, so we're going to leave that as a -6. Now, the next part that we're going to look at is we have c to the fifth on top, c to the second on the bottom. And so 5 minus 2 is 3. So it becomes c to the third. Then we have d to the second and d to the fifth. So 2 minus 5 is -3, so d to the -3rd. And then we have e's. Now, the e's are a little tricky, and I apologize, the c to the third is kind of covering that up a little bit. Let me back this up a little bit. I'm going to do this over again so it's a little easier for you to see. All right, so we said there's a 1 on the top and there's a -6 on the bottom. We can see 5 minus 2 is c to the third. And then the d squared, d to the fifth, is d to the -3. Now, looking at the e's, if you notice right here, these e's, they're actually exactly the same. You have e to the -3 on the top and e to the -3 on the bottom. When you have the exact same term on the top and the bottom, you can simply cancel it out. Now, thing to keep in mind, the bases have to be the same and the powers have to be the same number in order to be able to cancel. One can't be negative and one can't be positive. They have to be exactly the same. All right, so now you can see that we're one step away from being done with this problem. You have c to the third on top. Now the d to the -3 actually has to move to the bottom. We're going to leave the -6 there because once again, if the number itself is negative, it does not mean it goes to the bottom. It has to be the power that's negative. And there you go. There's your final answer for number 34. 35 is all multiplication. We did one right towards the end of the class, the practice problems of the last video that I posted. And this one, before we reorder anything, I actually underlined with colors, is we always want to double check in there and see that square. I kind of messed up when I circled it, but that square needs to distribute to everything. So we have to have -7 squared, and we have to have p. Now, p to the third and then squared becomes p to the sixth, and then we have r to the eighth, and then we have 6, and there's nothing to distribute in the second set of parentheses. So that's going to be p to the first. I'm just going to write that in there so you guys can see it. And then there's r to the third. Now, I'm going to try again what I did the last time. I'm going to underline my like terms here. We have this term and this term. Then we're going to have p and p. And then the last term we're going to have is going to be r and r. And so as we're looking through this, we're just going to leave it as -7. And yes, that -7, actually, I messed this up, should have parentheses around it. And then you have 6. And then the p's are p to the sixth, p to the first, which is going to be p to the seventh. Remember, the powers add whenever you're multiplying the bases. And then we have r to the eighth, r to the third. That's r to the 11th. And there's your final answer. You can leave it like that. If you want to multiply it out, -7 times -7 would be 49. And then 49 times 6 is going to be 200. Oh, let's see here. 294, I think, something like that. close enough. Um, but you don't need to multiply it out. You can leave it like that. All right, number 36. Looking through, nothing to simplify in the numerator, nothing to simplify in the denominator. Actually, that's not true. The denominator has a y to the 0. Remember, anything to the 0 is 1, so we can just cancel that out. Now, looking in the numerator and the denominator, there's a 4 on the top and a 3 on the bottom. Those cannot simplify, so we're going to leave those alone. We have x to the first on top and x to the negative 1 on the bottom. So what it ends up being is 1 minus and then negative 1. Now, when you do 1 minus negative 1, it becomes 1 plus 1, which is 2. So this is going to become x to the second right there. And then there's just a y to the fourth on the top. There's no y on the bottom anymore. So that's your final answer. 4x squared y to the fourth over 3. Okay, let me scroll down here a little bit. There's number 37. 37 is similar to the one that we just got done doing. 37, we have a squared, though, that's going to need to be distributed out. So let's take that. We're going to have negative 3. Don't forget about your parentheses like I did in that last problem. And then you're going to have j. And the j is already squared, and it's being squared again. So you multiply, so it becomes j to the fourth. And then you have k to the sixth. And then you have 2 to the third. We have j, those multiply. 2 times 3 is 6 again. And then we have k to the third. All right, so I'm going to go by, underline all the like terms again. We have red terms. And then we have, let's go with green. And there's our green terms that are going to combine. So those are all the terms that are combined. You don't have to multiply out the numbers if you don't want. You just still need to make sure that negative 3 is in parentheses, though. Negative 3 squared times 2 to the third. And then we have j to the fourth, j to the sixth. That becomes j to the 10th. And then we have k. We have k to the sixth, k to the third. That needs to be k to the 9th power. Okay. Now, looking at number 38. This one is all multiplication all the way across, but this one does not have a power outside the parentheses like the last problem that we just did. So we can just combine all our like terms. I'm going to use the same marker here. There's a j here, there's a j there, there is a k here, a k here, and a k there. And there, let's use blue. There's an L and an L. Okay, so the color coding is going to be what we combine. And starting with the j's, we have j squared and j squared. So that's going to turn into, mark a line right here, j to the fourth. Remember, we're adding powers when the bases are multiplying. The k needs, they're also going to add up. Now we have 3 on the first red k, and then 4. 3 plus 4 is 7. And then we also have an 8, which is 15. And then the last one is L, and we have L squared and L to the fifth, which is L to the seventh. So you have J to the fourth, K to the 15th, and then L to the seventh. All right, number 39 has one of those goofy giant dots again, but that just simply means multiplication. But before we deal with the times x to the third, we need to deal with this x, this cube right here that is affecting everything in the parentheses right there. So that 3 needs to go to everything. So it's going to be 2 to the third, and then it's going to be x to the power to a power. We multiply, so it's going to be x to the 12th. And then we're going to have x to the third. And as you can see, the x's are like terms. They're going to multiply. The bases are multiplying, but the powers themselves are going to add. So it becomes x to the 15th. All right, guys, we're on the last row. Um, let's scroll this down a little bit so we have some room to work. And let's look at this one. Once again, look at the numerator, nothing to simplify. Look at the denominator, there's nothing to simplify. You always want to check that first. Then we're going to move on and check these lead coefficients. It's 9 and 81. So 9 and 81 are the greatest common factor is 9. So the numerator, the 9 is just going to go away. And then the bottom becomes 9 because 9 divided by 9 is 1. 81 divided by 9 is 9. Now, looking at the a's, we have a squared. I'm sorry, we have a to the negative 2 over a to the third. So it's always the top minus the bottom. So we have negative 2 minus 3, which is going to give us a to the negative fifth power. And then we have b to the first on the top, and we have b to the negative 2 on the bottom. 1 minus negative 2 is, here, I'm going to show you, 1 minus negative 2 becomes 1 plus 2, which is actually 3. So this becomes b to the third. So this is one of these weird kind of instances where we still have other stuff to do, even though it almost seemed like we were going to be done because the power itself cannot be negative. So the a to the negative 5 needs to go to the bottom. The b to the third is still on top, okay? Um, but we're going to have the 9 on the bottom, and then we have a to the fifth. There's your final answer. Now, the next one has some of these big dots in there again. Again, it means multiplication, not a big deal. We need to deal with this first, though. That fourth power needs to get distributed to everything. So we're going to have y squared, and then we're going to have 2, then x to the third, y to the fourth, and then we're going to have 2 to the fourth again. And then we're going to have x. Now remember, it's a power to a power, so it multiplies, becomes x to the eighth, and then y to the 16th. Now from there, I'm going to color code stuff. We'll get rid of, there's the y, there's another y. Let's go to, here's a 2, and we'll go with purple. There is an x, and there's an x. So let's start with the numbers. This is tricky. If you look under the red, the first red, this is 2 to the first power, and then the second one is 2 to the fourth. So as you can see, the bases actually match. So we're going to rewrite that as 2, and remember, just the powers add. So it's 2 to the fifth power. Then we're going to combine the x's because we want to write them in alphabetical order. So we have x to the third, and then we have x to the eighth. 8 plus 3 is 11, so this becomes x to the 11th. And the last one, we have 3 y's we need to combine. We have y squared and y to the fourth, and then y to the 16th. So 2 plus 4 is 6. 6 plus 16 is 22, so this ends up being y to the 22nd power. All right, last one. Nothing to simplify on the inside. The 3 on the outside needs to distribute to everything. So we're going to have negative 3 to the third. Then we're going to have w. Now notice the w is to the fifth power, and then it's also being taken to the third. So you multiply, so it's w to the 15th. And then you have x squared, and that's going to multiply, so that's going to become x to the sixth. And that is actually the final answer. There's nothing else to do there. And with that, guys, we finished up the set of practice problems. So I hope you guys are all doing well. Please feel free to email me if you have any other questions or need anything else. Take care.